There, that was just for making myself less nervous. I'm actually very glad that we are back to the classroom. Earlier I used to think like I'm teaching my laptop. Very bad experience. It never gave me a single correct answer. I hope you will. Will you or will you not? Will you give me correct answers? Yes. Yes. Sure. You don't seem to be so sure, right? There's no strength in your voice. Okay. Right. Only Krisha is sure, other girls are not. Okay, so let's start. So first thing that we are going to learn about fluids is the meaning of the word fluids. Fluids means anything that can flow. Flow. Does the chair flow? Can you give me examples of a few things that flow? Water can flow, alright. What else? What else can flow? Give examples of materials that can flow. Once again, this camera, I don't like it because I want to get down the stage. I want to walk here, I want to walk over there, I want to roam here and there, I want to fling chairs across the room. Right? Yeah, okay, continue. Let's continue. Come on. Which things can flow? Hurry up. Water can flow. Yeah, very good. What else? Say it. Come on. Liquid can flow. Give examples of liquids. Oil. Okay. Then milk. Okay. Petrol is a liquid. Alright. Oh, yeah. What else? Blood can flow. Yeah. Okay. Only liquid can flow. Solids. Yes or no? Can solids flow? No, can't flow. What else can flow then? What else can flow? So much here liquid. Why should we write liquid here? Properties of liquid. Can air flow? Yes or no? Yes or no? Yes. I'm sure all of you can answer that. And everyone knows the answer as well, right? Can air flow? Yes. Okay, air is a? Yes. Yes, right? Air is a gaseous state. So can gases flow? Yes. Yes. So what are fluids? Fluids are those things that can flow. So basically fluids can be further divided into two parts, liquids and gases. Okay? Liquids and gases. Out of all that, in this chapter mostly we are going to focus on liquids because they are incompressible. We had this in the previous chapter in one of the numericals. Right? That liquids are incompressible. Right? That is, you can press them hard, you can apply a lot of force on them, a lot of pressure on them, but still the volume decreases very little. Okay? That's going to be our focus. What about gases then? Don't we have to study about gases? We will later. Kinetic theory of gases and all that. Okay. You might have studied about gases in chemistry. Ideal gas. Yes or no? Yes. Ideal gases, not noble gases. Ideal gases. Right? Okay. So we are going to mostly focus on incompressible fluids. That's basically liquids. Okay. Now, the first thing that we are going to talk about is pressure. Right? The first thing that we talk about is pressure. You all have studied pressure probably in 9th standard or 8th standard. 9th standard. Okay. One more thing that I'd like to suggest, this frankly your first time meeting over here in class, please note down things. Okay? Because let me tell you, I'm very, very lazy. I hate to write it on the board. If I could do, I would explain all the physics by words. But it cannot be done. Somewhere you'll have to write, somewhere you'll have to use math, so we cannot do it that way. So whatever I am writing on the board, that's extremely important, only then I am going to be writing. Clear? So whatever is on the board must go in your note. If it doesn't, you are going to miss out. Okay, and now I would never ever summarize the important points for you in the class. Clear? Obviously I did stop before a while, right? But in the classroom I will never do that. Okay? So you'll have to make your notes on your own. Of course I'll tell you that this is a very important point, but you'll have to note it on your own. Okay. So pressure. So in 9th standard you would have studied that pressure is equal to force upon area. And that is force acting per unit area. Well, I'll tell you this is slightly incorrect, like many things that you have studied in 9th. Okay? Let me give you an example. Suppose you think of, let's think of this board itself, right? Board is a surface. And I mark a particular area of this board. Okay, and I'm going to apply force on it. Okay, in hope that this wall will break and my hand will go into the next class. Okay, not going to happen, but worth a try. Okay, so if I am going to push it, what I am doing is I am applying force, right, on this area. So there is pressure, which you can say is F by A, but things are a bit strange. It's not as simple as that. See, what would happen if I apply force at an angle? Right? Apply force at an angle. In that case, this doesn't work. Let's see the side view. Suppose this is the surface, maybe something like that. Right? Okay, that's what I wrote. Clear? You can see it like this only. Am I right? Side view. Okay. So here, if someone would apply 10 Newton force in this direction, that's case 1. And in case 2, if someone would apply 10 Newton force but in a different direction, let's say 30 degrees. The truth is that the pressure is not same in both cases. Pressure is not same in both the cases. Although the force is same, area would be same, but still the pressure would not be same. Right? So what is the proper definition of pressure? It's definitely not this, correct? Okay. So it is as follows. Pressure is the normal force component acting per unit area of surface. Basically, we have added a few words to the definition you learned in 9th standard. Am I right? In 9th you would have learned what pressure is force per unit area. Okay, you all speak. Right? So continue like that. Okay. So pressure is the normal force component acting per unit. So for example, I will find out how much the pressure here. So first of all, I have to find the component of this force which is in the normal direction. Laws of motion. We have learned how to find components. We have also learned what is meaning of normal. Correct? Normal that is what? Normal means perpendicular to the surface. Okay? Ooh, chapter 4. Isn't it? No, 5. 5 actually. Laws of motion, chapter 5, yeah. Okay, so if I want to take components, I'll have to do it by 10 cos 30. Clear? Okay? So that's the change. What do you think is the unit of pressure? Force Newton. Right? Actually, if you want to modify this, you can just write it like this. F perpendicular. You understand what is meaning of that? F perpendicular. F perpendicular means force acting normal or perpendicular to the surface for unit area, right? So this is a useful thing. In my view, this definition, this formula both tell you the same thing. And I really like that because you have been studying in English medium from the first. You would be able to convert sentences to mathematics or mathematics to sentences, right? So don't do the double work, right? There is no need to stress it out. Just remember one. You can easily convert it to words. It would be correct. There will be no doubt, right? Yeah. But if you forget important terms, for example, you forget this, then that's not going to work. You should watch everything carefully. Force perpendicular component divided by area. That is per unit. Okay. So I recommend that you remember any one, either the words or the formula. Normally people prefer to remember formula, and I also prefer to do that. Okay? Right? It's very easy to convert this to words. Right? Units. Newton for force divided by what? Area, meter square. Right? So the unit of pressure is Newton per meter square. But we call this Pascal. 1 Newton per meter square is called 1 Pascal. Okay? 1 Newton per meter square is called 1 Pascal. Right? Okay. So don't forget what is 1 Pascal. Now, a very basic way or a very basic thing related to this unit is, can you convert 1 Pascal to dyne per centimeter square? Do it at home, okay? This is your homework. Can you convert 1 Pascal to dyne per centimeter square? Pressure does have other units, like what? Name them, come on people. What other units of pressure do you know? From chemistry maybe? ATM. ATM, bar, Tor. Okay, you know that, right? Interesting. What else? Heard of this of Hg? Yes? I believe you would have said all of this in chemistry. And I believe I don't have to repeat. Sure? It's okay if I don't repeat them? Thanks. So, obviously 180 stands for atmosphere. And value is 1.013 into 10 raised to 5. 5 what? kg? Pascal. Don't forget this. Okay? 1.013 into 10 raised to 5. What's 1 bar? 1 bar. One bar or tome bar? Which one? Come on. Hurry up, people.
760.
SI units. 1 bar is how many SI units? Because generally we do calculation in SI. That's right. Okay. Anyone? Well, it's the easiest possible. Exactly 10 raised to 5. This is not exactly 10 raised to 5. Am I right? You understand what I'm saying? 1 bar is exactly 10 raised to 5. Okay? 1 Tor. 1 Tor. Come on, people. 1 Tor is equal to that. Who gave the answer that 1 bar is 760 torque? Okay. Yeah. Rushabh, correct? See, I didn't have to say green t-shirt. Right? So Rushabh, you said that 1 bar is
1 bar equal to 1 torque.
1 bar equal to 1 torque. Earlier you said 1 bar equal to 760
1 torque equal to 1 mm of H. Equal at very.
But I want it in SI unit. That's what I'm asking. So 1 bar is 760 torque. You know what is torque short form of? Any idea? No idea. Torque stands for torically. Right? Torque stands for torically. The person who first derived this equation. Right? And he did many more things. We'll study all that in this chapter. But I'm sure you recognize this equation. Right? If you don't, life is going to be hell. Okay? So, nevertheless, that's history. We don't have to worry about that. Okay. So 1 bar is 760 torque. So if I want to convert 1 torque to SI unit, how could I do that? Use these relations. Come on. 1 bar is 10 raised to 5 Pascal. And 1 bar is 760 torque. So 1 torque is how many Pascal? That's what I'm asking you. 1 by 760 into 10 raised to 5. Into 10 raised to 5. Sure about that? So this is what you are saying. 1 upon 760 into 10 raised to 5. Let me verify that. So 1 bar is 10 raised to 5 Pascal. Yeah, you are. Okay. Clear? See, this is how we convert units, and you should have practice. I will expect that everyone can convert units from one to this. It's not tough. It's just like 9th standard, isn't it? Just multiplying, dividing here and there. Okay. So this is 1 torque in Pascal. And like he said, 1 mm of Hg is same as 1 torque. Okay. So that would be once again 1 by 760 of ATM, or 1 by 760 into 10 raised to 5 Pascal. Okay. So this is about a few units of pressure. Frankly, I don't know, I don't remember what's the Cgs unit. Do you know what the Cgs unit of pressure? SI unit Pascal. What's the Cgs unit of pressure? Sorry? No. Dyne is for force. Okay. So it's obviously dyne per centimeter square, but I don't know whether it has a name. Right? I will admit that I don't know. Right? You all should also learn to admit. When you don't know, don't try to do anything else. Just admit you don't know and try better, try harder. Okay. Maybe there is no name. Possible. Right? Dyne per centimeter square has no name. Well then, that's what you need. Erasing everything else. I was missing that. સારું છે ન્યૂટન લોઝ ઓફ મોશન નથી પણ એની તને છૂટા ડસ્ટર આમથી આમ જતા હોય ખબર ક્લાસમાં ઓકે ન્યૂટન લોઝ ઓફ મોશન એન્ડ પ્રોજેક્ટાઇલ મોશન ઓકે then I have to say first benchers wear a helmet. Okay, so now we are going to talk about variation of pressure with depth. So this topic is about a fact that you already know, and that is as you go deeper inside a liquid or a fluid, what happens? The pressure will increase. Alright? Neil, now you can come back to it. It was boring over there. So, variation of pressure with depth, as you go deeper the pressure increases. So we are going to answer two questions. Why, first of all. And the second thing is, how much? Right? We say that pressure will increase, alright, but how much? Understood what we are trying to discuss over here. And we are going to do this for incompressible fluids. So practically liquid. Right? Why are we doing it for incompressible fluids? To save you all from the maths. Right? It's not like if we do it for compressible, it's very tough. Okay. But first let's do it for incompressible. Right? Questions related to compressible fluids or variation of pressure for compressible fluids are asked sometimes in the exam. Right? At least they have not been asked in the last few years. They have gone easier. Okay. But it could be asked, you can go. Right. So first of all, incompressible. Let's say this is a vessel. And here is the fluid. But like I said, we are talking about incompressible, so likely we are talking about liquids. So I have shown a liquid, gas with ODI. Okay? First thing to understand is what is meaning of a surface. How many of you can define a surface? Or tell me something about the surface. What would you call a surface? I'm waiting for you. What would you call a surface? See, there is no right wrong answer. Okay, don't worry. And please don't worry that others are going to make fun if you give wrong answer. There is no such thing. It's probably that if someone doesn't answer, they don't know. Right? So I would say in this classroom there is only one person who is capable of deciding whether it's right or not, and that is me. Okay, and I am going to make fun, yes, if you don't answer. પછી મારે કેવું પડશે કે પેરાલિસિસ થઈ ગયો, બરાબર ને? So try answering this question. What do you understand by surface? Yes, Sujit.
First layer.
Can you please stand up and say it loud so that everyone can hear?
First layer of fluid.
First layer, okay. First layer counted in from where? From here? From middle? First from where?
From top.
From top. Okay. Right. So you mean here. Okay. How many of you agree with what he said? The first layer over here is called surface. You disagree? Then what is your opinion? It's not that. Then what else could it be? No? Yes, follow.
Outermost layer of any object which you can touch.
Okay, so you are saying outermost layer. The first layer, okay, that was in simple words. Now Golak is saying outermost layer. So it could be this. Would you call this one here outermost? No? Okay. This one? The one at the bottom? Never mind, well tried. Well tried, Sujit. Sit down. Okay, see, this will happen often. I'm actually very happy that two guys over here tried to answer questions, right? And next time, I hope everyone will participate. Like I said, please don't worry about right or wrong answers. Okay? Take part in the discussion. Alright? કે હવે ઓનલાઈન એટલું ફાવી ગયું છે કે હવે આમાં મજા નથી આવતી. એવું નથી ને, ઘરે બેઠા છે આ ઉપર આમ જોતા આકાશમાં શું કરે? કીધું તો યસ. I was excited. I will get one more student. Turns out it was a ghost. Well, so what's a surface? A surface is a layer where two different materials or atoms or molecules from two different layers come in contact. And repeat what I've said. A surface is a layer where atoms or molecules from two different substances come in contact. A layer where atoms or molecules from two different materials come in contact. So let's take examples of surface. Look at this line. Remember, surface is actually an imaginary line. Okay, surface is imaginary thing. Think of this imaginary line. What's below this line? Liquid. Correct? Yes or no? What's above this line? Air. Okay. So do you agree that's a surface? Read the definition. It's a layer or a line across which you have two different materials or molecules of two different materials. Agreed? Okay. Let's take one more example of surface. Look at the bottommost view. What's above this line? Liquid. Below? Glass. Suppose this is a glass beaker, then glass. Suppose it is made of steel, then steel. Alright? Everyone understood that? Okay. I see many of you are wearing glasses, like me. Look at the glasses. How many surfaces do the glasses have? 2. Am I right or not? Those who wear glasses know that you have to clean on both sides. Right? And it is very irritating. Correct or not? 2 surfaces. Why? To think about it. On one side you have glass at the center, air on this side, so one surface, air on that side, so one more surface. Make sense? Yes or no? Yes. How many surfaces does your skin have? How many surfaces does your skin have? 1 only. 1 only. Let's have a look at the hand. This is one surface. Do you see the same thing bends over here and goes there? It's not separate. You understand what I'm saying? It's different from here. For example, air, liquid, one surface. Liquid, glass, another surface. Correct or not? But is that the case with your skin or with your body? You understand what I'm saying? Sure. So that is surface. Right? So now we are going to talk about what happens here at the surface in this open vessel. Over here at this point. Over here at this point. Do you realize that the air above this, let's say we are doing it under normal circumstances where there is air above. So air will apply pressure at this point, yes or no? Yes. Sure, everyone understands that atmosphere applies pressure on you. Over here, and over here, everywhere. Right? But let's focus on this question, this situation first. Over here, the pressure is applied. It will be over here, everywhere on this surface, upward surface. Okay. How much will be the pressure on this surface? Atmosphere. 1 atm. Who understood that? I am saying the pressure on this surface is 1 atm. Yes, no? Yes. Raise your hand if you have understood. Please don't be shy. Okay. Do you realize that above this surface there is air, that is atmosphere, and you know atmosphere applies how much pressure? 1 atmosphere under normal circumstances. So definitely the pressure at this point A is not 0. Clear? Suppose I mark the point A here. Is the pressure at A 0? No. If there is air above, it won't be 0. Right? Okay, so let's say pressure at A is P. Let pressure at A be P A. Alright? Pressure at A, P A. It could be atmospheric pressure, it could be anything, no problem. Right? Now, let's go to some point which is below that. Let's say here B, over here. Right? Let's mark the point B over here. I will just draw it on the side. So this is B. Now, I am interested in finding what's the pressure at B. That's what this whole derivation is about. What is P? Okay. Provided that suppose this is at a depth H. Okay. If you don't like H for depth, you can use Z. Some people use D. I don't know. We are not going to use D for density. We are going to use rho for density. Okay. So you can either write Z or D or H. Right? Okay. Tomorrow onwards, I recommend that you all start sitting on the second bench, not the first, because you will not be able to see anything. Okay. So, we want to find out what the pressure is in terms of H. Let's start. I am going to think of an imaginary cylinder. Why cylinder? It could actually be any shape, but cylinder makes the math very simple. Suppose there is an imaginary cylinder like this. Okay, can you see that imaginary cylinder? So let's write, consider an imaginary cylinder as shown. Its cross-sectional area is A and height H. Right? I hope you understood what I am writing was about the cylinder. Its cross-sectional area means the area of this circle. How much is the area of this circle? A. Right? And the height is. Now we are going to get a relation between these. So time to draw FPD. Right? Let's begin. So here is the FPD. So far we have been talking about forces like weight, normal force, tension, spring, etc. Right? There are no such things. Only one thing though, weight. This is a liquid. Inside this cylinder there is going to be some liquid, correct? And liquid has mass. Am I right? So if it has mass, it will definitely have points for FPD. If it has mass, it has weight. First point of the net. Because the bully range on mg. Clear? Okay or not okay? M downwards, obviously. Right? Now, what other forces could be acting on this? Like I said, at this upper surface, there is a pressure. How much pressure? PA, 1 atm. But we are talking about a general case where it could be anything. Then we can always put value 1 atm. So right now, let's say the pressure is PA. That pressure, do you realize, is going to push it down? Air pushes the object down, obviously. Yes or no? But PA is a pressure, it's not a force. In FPD, we should not write pressures, we should write forces. From pressure, which is in this direction, I can easily find force by multiplying by area. Yes or no? Force perpendicular to the surface is equal to pressure into area. Agreed? So pressure into area. What is the area of this circle? A, like I mentioned earlier. So that force is pushing it up. This one. Similarly, over here also there is pressure. Yes or no? Right? And that will push it up. Clear, everybody? So this here is another force which is because of the pressure over here. So this force is PB. Clear? Okay. Now what about left, right? We have talked about up and down. What about left, right? Let's think of it. Do you realize that because of the nice symmetry of the cylinder, whatever force will apply from the left side, the same force is going to be applied from the right side? Cylinder both the same. Do you agree? Look at, if you just look at this part of the pen. same from all sides. Correct? What that means is force applied from here will exactly cancel the force applied from opposite side. Yes or no? And because you see, because fluid is everywhere, this cylinder is surrounded by fluid. So just like air applies pressure in every possible direction. Suppose you raise your hand like this, then air will apply force over here, over here, over here, over here, over here, everywhere. Right? That is what a fluid does. Okay. So just like that, this liquid surrounding it will apply force from all sides, but horizontal forces are all cancelled. Clear? So ultimately, you can say that for equilibrium of this part of water or fluid, whatever that is, okay? For equilibrium of this part of fluid, what is the meaning of equilibrium? Total net force is 0, right? Total force is equal to 0. So, let's take upward positive, downward negative. Okay. So, which forces are acting in upward direction? Look at the arrows carefully. Which force acting in upward direction? PBA. Clear? PBA. Minus. Which force acting in downward direction? Hurry up, hurry up. PAA. Okay, any other force acting in downward direction? MG. Very good. Minus MG is equal to 0. Equilibrium. Right? Now, we are interested in finding what is PD. So, PD. Over here, minus PA. A is common, isn't it? And you see A is common, is equal to mg on that side. Now mass. How do you write mass? Mass of a fluid can always be written as density into volume. Please don't forget this. Mass of any fluid or any other object, in fact, gas or solid or anything, mass can always be written as density into volume. Okay, this is something that you should remember. So instead of this m, I should write rho into V. Okay, what's V here? V for volume. Volume of what? Of this cylinder. So what's the liquid inside it? Right? So the volume is V. Clear? Now that volume V, I'm sure you have learned it in 10th standard, that this volume of a cylinder is going to be equal to AH. I think we talked about it just before a couple of days when I was explaining the energy stored in a stretched wire. Never mind. Do you remember that volume of a cylinder is pi r square h? Pi r square શું છે? તો પછી શું આટલું બધું વિચારો છો? Okay, get used to it, everyone. Okay, volume is equal to cross-sectional area into length of that cylinder. Okay, pi r square is the area of that circle at the end. So, instead of V, in the next step, I'm going to put AH. Clear? And we are almost there. What do you think should be the next step? I'll put V is equal to A to H. What do you think should be the next step? Louder! What do you think should be the next step? Cancel A from both sides or divide A on the other side, right? Okay, so we'll get a final formula, and that is going to be PD is equal to PA plus rho G. Clear? Should you remember this formula? Of course. Okay, if you won't remember this, you will have a lot of trouble with this chapter. Right? PB is equal to PA on that side plus rho G. Below this formula, write terms. Come on, people. Draw the diagram, of course, if you have not drawn it yet. Okay. Show this H. H is the depth. Alright. H is the depth. From where? From the surface, upper surface. Right. So if you are writing terms, I'd say H is equal to depth of B from level of A. Let's generalize it. See, it is also not necessary that A is on surface. This same relation can be derived in any case, even if A is not on the surface, right? So H is equal to depth of B from level of A. Do you understand what this sentence means? Yes or no? Suppose A would be here. Then when you use this formula, you will take only this much as the depth. Understood? Okay. So H is the depth of B from level of A. Rho for what? Density of fluid. Okay, density of this fluid. Okay. My handwriting is worse on the board. And G. Gravitational acceleration, which we take 10. Okay, or 9.8 if we have to do it. Okay. So that's it for this particular. So, as a very quick fire homework question, right? Very simple. You will not have to write anything, don't worry. Just think that if there is a point in the ocean which is 1 kilometer deep, you understand what I am saying? Think of a point in the ocean which is 1 kilometer deep at the bottom of that ocean. Can you find out the pressure at that point using this formula? What's the pressure on the surface? 180. But don't forget to use SI. Okay? Homework clear? What do you have to do? Find the pressure at the bottom of the ocean, assuming it is 1 kilometer deep. Okay? Please turn off the recording.